The next topic that we have is coupling and cohesion. Okay, so when a software program is decomposed or is divided into smaller modules, okay, then it is decomposed based on certain characteristics. Okay, so as we know that modules are nothing but what? They are a program only or set of instructions, isn't it? Which is clubbed together so that we can get certain tasks done out of that. Okay. So when we talk about modules, they are considered as one entity only, as one set only. They are not taken as differently, okay? And there may be various modules in a particular program. Many paths may be there, okay? Now, when we are measuring the degrees of interaction, the degrees of freedom that the modules may have with one another, isn't it? That means the interrelationship that they may have with one another. So these are measured with two terms called coupling and cohesion. So what is cohesion? Cohesion is basically a measurement that tells us like how much dependency basically the modules have with one another. Okay. So cohesion is nothing but the measurement that tells us that how much amount of dependency is there within the elements of a module. Okay. So there may be various factors, there may be various elements of a module. So it is said that the more the cohesion it is, the better it is for the design of the program or of the module. Now, there are various kinds of modules like cohesion, logical cohesion, temporal cohesion, procedural cohesion, communication cohesion, sequential cohesion, and functional cohesion. So these topics are very, very important. Okay, cohesion and coupling, they're asked only for 7 to 8 marks. So you have to know these things very, very properly. Okay, and since I'm giving you the study materials also, so making the lecture notes also now it will not be tough, but just you have to add certain examples from the book. Okay. So first of all, what is coincidental cohesion? So from the name itself, coincidental means what? Something which is unplanned and certain things which happens randomly. So this happens when does this cohesion or the degree of relatability between the elements of a module, when does it take place? This takes place when we have broken down the program into smaller modules for the sake, okay, we should break up. Okay, that for that sake only, I've divided the big program into smaller sections, okay, in an unplanned and random way. That means I did not check, okay, are there elements which are related to another? Are there elements, which have certain same features or not? So in this case, we give rise to a cohesion. That means there are certain interrelatability among the elements of a particular module, but that is unplanned, okay. Logical cohesion takes place when we have, let's say, many elements in a module, but those elements which have similar kind of nature or similar kind of, or those who are similar type, when they are put together, so that is called logical cohesion. Let's say, for example, if suppose in a particular module we have an attribute date of birth and then we have attribute age also, so I think those can be take clubbed together, because if I know date of birth, I can find age, isn't it? That is something like that. So that is something called logical cohesion. Temporal cohesion means when elements of a particular module are organized such that they are processed at a similar point in time is called temporal cohesion. So that, let's say, there may be several elements in a particular module, but if all those elements of one module is processed at the same period of time, then we say that all those elements are linked together through a cohesion. That is what kind of cohesion? Temporal cohesion. Then next is procedural cohesion. So this takes place when elements of a particular So this takes place when you have elements in a module, they are grouped together, but all the elements are not executed at the same period of time. Like in case of temporal cohesion, the execution takes place in a sequence, okay, one after another. Okay, yeah, I actually went off, no, that's why. So procedural cohesion basically takes place when do we say that, this is the case of procedural cohesion? When suppose we have grouped the elements together, but the elements are not executed together, like in case of temporal cohesion, but in a sequential way. Like there are 5 elements in a particular module. So one after one has finished, then another like element will be, or information will be processed. So that is basically your procedural cohesion. Okay. Then next is communicational cohesion. So this when do we say that this is a case of communicational cohesion? So when suppose the elements of module are grouped together, but the but the elements are executed sequentially. That means one after like one has finished execution, and the part of the module they work on the same data. That means you have different modules, but all the modules are working on the same information or on the same data. And sequential cohesion. So when elements of a module are grouped, because the output of one element serves as the input to another, and so on, then we say that this is a kind of sequential cohesion. Okay, so let's say the output of one element, okay, there are 5 elements again. If one has finished, it will generate an output. That output will be an input to the second. Then again for the second, it will generate an output. That output will be an input to the third one, and so on. Then functional cohesion, it is considered to be the highest degree of cohesion. It is highly expected. That is one of the best. Okay. So elements of module in functional cohesion are grouped because they all contribute to a single well-defined function, and it can also be reused. Okay, so this kind of cohesion is highly preferred. Okay, and elements of module in functional cohesion are all grouped. Okay, because they all together contribute to attaining one single output only, and this can be reusable also if suppose we have certain modules similar to uh, the functional cohesion. Okay. So coupling I will do tomorrow. So basically you will be asked only questions. Again, I'm saying what is coupling and cohesion? What are the various types of coupling and cohesion? Which cohesion is mostly preferred? Which coupling is mostly preferred? Okay. Then this line also, the greater the cohesion, the better is the program design. So they will I like ask like this: the dash the cohesion, the better is the program design. So the greater that way have to know. Okay, so you can list. So tomorrow I'll be doing coupling, and then I'll be moving towards the data flow diagram, which is very important for your project. Okay, I'll take some certain sample examples also, and I'll teach you. And you have to focus a lot because DFD is something that students have to know. Okay, very nice. So any questions? Any questions, anyone, or it's fine?
No question.
Attendance, have you taken? Okay, attendance, have you taken? Oh, okay, then we can stop here for today. Tomorrow